All right, so for those of you who wanted a little bit more review on our basic functions, because I didn't get quite to everything in class, I wanted to quickly go over sort of the last few. So starting with the exponential function right here. F of x equals e to the x. So e is the transcendental number 2.72, blah, 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 blah. As long as you know 2.72, just like how pi is 3.14 and more, e is 2.72 and more. If you know 2.72, that'll be enough to help you plot points and sketch this graph. So the two most important points to be able to plot for this graph are when x is 0, right? E to the 0 is 1, and 1. E to the 1 is e, and that's about 2.72. What you'll notice when you plug in negative values, because again, negative exponents mean take the reciprocal, right? So e to the negative 1 is actually 1 over e, and that's about 0.37, so that's down here. And anything else is just going to get smaller and smaller and smaller, and it's going to give you a horizontal asymptote, but for the left side end behavior only. The right side end behavior, as x gets bigger and bigger and bigger, you're getting bigger and bigger and bigger, and it's growing exponentially. So this is what your graph looks like. I would not expect you to know these values without a calculator. I do expect you to know these two values without a calculator. So if I were to ever quiz or test you on this function, I might give you these values already to help you plot it if you want, but I'd expect you to know these ones without a calculator. So the domain of the function is all reals. The range is 0 to infinity, not including 0, because of that horizontal asymptote, right? It never actually equals 0. Again, e to the what equals 0? Never. There's no exponent that will ever make this equal 0. So, is it continuous? It's continuous, yes, everywhere, on its domain everywhere. Is it increasing? Yes. For all real numbers, it's increasing. It's never decreasing. There's no symmetry. It's not even. It's not odd. It is bounded below by 0, even though 0 is not in its range. 0 is the greatest, no, it's the greatest lower bound. Yes, I said that right. The greatest lower bound. And yet it's not in the range. So that's interesting. And because it's not in the range, there's technically no minimum value. You get infinitely close to 0, but you never actually equal 0. Y is never actually equal to 0, so there is no minimum for this. It's just getting infinitely close to 0. And clearly no maximum because it goes up to infinity. There's no vertical asymptotes, but there is this horizontal asymptote on the left side only, right? The right end behavior, y is running to positive infinity as x goes to infinity. All right, so now the exponential function is the inverse of the natural log function. So natural logarithm ln of x. What this means, let's do a little bit of review. You may not remember. If y is equal to ln of x, this is telling us that e to the y is equal to x. So the natural log of x is basically like saying what exponent on e will give you x. So if you were to plug 0 into the natural log function, that's kind of like saying, well, e to the what will give you 0. And as we just saw in our previous example, there is no value. This is undefined. There is no value. 0, not in the domain of the natural log function. How about 1? E to the what will equal 1? Well, e to the 0 will give you 1. So when x is 1, y is 0. How about e? E to the what will give you e? Well, that's 1, right? E to the 1 is e. So what was e? E again was about 2.72, so 2.7, maybe about right about there, right? And if you can plot those 2 points, good enough, right? To give you, well, I probably should be careful, not quite good enough. If you can plot those 2 points and recognize that there is also a vertical asymptote, where the vertical asymptote is, again, if you plug in -1/2, I'm going to do a different one. If you plug in, not negative, if you plug in 1/2 for x, again, that's like saying, well, e to the what will be the fraction 1/2. Well, that's going to be a negative exponent, right? This is negative point, I think it's negative 0.7. So it's about negative 0.7. So here's 1/2, so negative 0.7 would be maybe about there. And what you see is the closer you get to 0, the more and more negative you're going to get. So your graph, right, as x gets closer and closer to 0 from the right side, which my video is reflected, so this way, right, as the limit as x goes to 0 from the left of the natural log of x, that's going to equal -infinity, right? And we're going to have a vertical asymptote at x equals 0. VA, vertical asymptote at x equals 0. By the way, I realize there was a slight typo here. This is not a vertical asymptote, that's a HA, horizontal asymptote here. Notice, horizontal asymptote at y equals 0, and then when you flip all of the x and y values, because they're inverse functions, sneak peek at something to come, you're going to get x equals 0 is the vertical asymptote. There are no horizontal asymptotes, none, because we can plug natural log of 4.5, natural log of 7.4, natural log of 12.2, natural log of 20. When we plug those into our calculator, it gives us 4.5, that's about 1.5. 7.4, that's about 2. 12.2, that's about 2.5. 20 is about 3. So you can see it's growing very slowly, right? It only gets up to 3 here when you're way out at 20. Right, so that's off the screen. So 7.4, right, right here, that's when we're going to get to 2. And so it is growing very, very slowly, but it is still growing nonetheless. And in fact, it is going, the range, all real numbers. Y goes down toward -infinity here, and it's going to go up towards +infinity here. The domain, because of this vertical asymptote, is restricted for x only strictly greater than 0, right? For not including 0, but anything just above 0. Is it continuous on its domain? Yes, so continuous on 0 to infinity, its domain. Is it increasing? Yes, everywhere increasing. Yes, on 0 to infinity again, right? For all x values greater than 0, it's increasing. Is it decreasing? Never. Symmetric, definitely not even. If you rotate, it's not odd, so symmetry, none. Is it bounded? No, because again, my range is all real values. And max and mins, again, none, because my range is everything. The end behavior, right, as x goes towards +infinity, my y is going towards +infinity as well. The left side, however, as x goes to -infinity, there's none, right? There are no y values back over here, right? Because I've got a restricted domain. So that's the natural log function and the exponential function. And again, these are inverses of each other. Think about it. Look at these two graphs. This point here is 0, 1. This point down here is 1, 0. X and y are switched. The domain and range for my exponential is all reals and strictly greater than 0. Switch those, and the domain and range for my natural logarithm are strictly greater than 0 and all reals, right? They're inverses of each other. Inverse functions flip all x and y values, basically. So that's it for this one. I'll make another video covering a few other ones.